Okay, so grade 10 essential, you are most likely looking over this because the other groups are writing the quiz or the unit quiz on chapter 1. So we are going to spend a little bit of time. This is coming back later, but I find that the time we have then is usually too short to cover this in detail. Okay, so write this down on loose leaf. Okay, so I'm going to go through the notes. So trigonometry, right? The study of triangles, their sides and angles. Okay, so some of you will have seen this already in grade 9 here at Sisler, but it never hurts to review this. In fact, I would bet that you still need to see this one more time. Okay, so your task is to write these notes down on loose leaf and just make sure you follow and you understand, because I'm going to have some questions at the end for you. So a couple of things to note here. This trig that you're going to learn a different trig in grade 12, but here it only works with right triangles. What is a right triangle? Right? Has a 90-degree angle. So if you've done trigonometry, if you've seen triangles, if you see a little box, right, it has to have that in place or else this will not work. Okay, so let's label a triangle. So typically, right, I'm going to make it look in a couple different ways. So this is a classic look, right? You have your 90-degree angle. There are always 3 sides that you want to label, okay, on a triangle. So there's always going to be, this is always going to be 90. There's always going to be a 90-degree angle. And these other 2 are also angles which will be given to you, okay? So there'll be a number in here or in there. It depends, right? But let's say they give you this angle here. So it'll be marked like that, or there'll be a number in there. This is called the reference angle. Or I'd like to say this is where you're standing, right? So if you put your face right there and you look up, right? This is your reference. This is where you are positioned right now. You're coming to this angle because you know it, and you're looking out of that angle, okay? So there are 3 sides that you need to label. And the one across the 90-degree angle is always called the hypotenuse, which you will probably remember from using the Pythagorean theorem, right? C squared is equal to a squared plus b squared. So that stays the same across the 90. And the one that's across from the reference angle is called the opposite. So this side, it's opposite side, right? This is the opposite side. And the last one remaining is called the adjacent side. Okay, so this is the adjacent side. The whole length of it is the opposite side, and that's the hypotenuse. That stays the same. Adjacent means next to or touching. Okay, so think about it. If you're here, this side is adjacent to you. So if you say, you know, a superstore is adjacent to Walmart, right? That means that they're next to each other. They're close, right next to each other. They're almost touching each other sometimes, right? But it's a way of talking about triangles, okay? So that is always the case. But let's see if this is flipped, right? So let's say you have one of these, right? And the 90-degree angle is up here. Right? And let's say the reference angle is now here. So this is now a reference angle, and you're standing here on this triangle. Because remember, at the end of the day, we're going to have word problems where these side lengths are going to mean something, right? They're going to indicate the height of something or the distance, how far away you are from something. So where's the hypotenuse here? It's across the 90, right? So if you get that right, okay, that'll save you a lot of grief. Find the 90 across this hypotenuse, okay? Then the side that's across the angle, so you just drive out, and this is the opposite side, right? And the last one that is left is going to be the adjacent. So that's the one I always label last. So I figure out my hypotenuse, I figure out the opposite, and then the last one is the adjacent, right? There's only one left. So these are the three sides that are always going to be in play when using trigonometry, when using the trigonometric ratios, okay? Okay, so that's labeling, right? So that's labeling, right? Labeling sides. And then another thing I want you to know is that if you're ever given a triangle, right? So let's draw one like this, okay? Normally, the angles or the corner points are denoted by a capital letter. So if this is A, B, C, we call this triangle ABC. Okay. If you have if you see a triangle ABC, you're thinking of a triangle that has corner points A, B, C. And it doesn't matter if you were to go start with A here and go B, C counterclockwise or clockwise, it doesn't really matter. Your triangle might just look different, but the math, the resulting numbers will still be accurate and correct. Okay. Another thing you need to remember is that uppercase indicates angles. Lowercase indicates sides. Okay, so this is how we would label this particular one. I'm going to use a different color. So if this is A, capital, so we're talking about this angle here, across from that angle, this side would be called lowercase a. So when I say find lowercase a, you should know, or find side A, let's say this wouldn't be labeled yet, you just have the angles labeled. Find side A, you should know that it's the one across the angle. So across B, this one, you'd have lowercase b here and lowercase c there. So that's how you label. So this could be D, E, F, right? X, Y, Z, it doesn't matter what letters across from them, across from the angles, you put the lowercase in there, okay? I think one more thing is note, right? The hypotenuse is always the longest side. If that's not the case, if you do some math and you find that it's that side that you found is longer than the hypotenuse, you did something wrong. Something isn't right. You might get an error on your calculator or something like that, but you need to remember that. So let's dive into the trig ratios. There are 3 trig ratios, and each is used at different times. Okay, so let's say you have a triangle. Let's do this one more time. Okay, so you're given a triangle like this, and I will just, for illustration purposes, make this my reference angle, even though it could be the one up here. Okay, so let's call this a triangle ABC, right? Therefore, you would have lowercase a here, lowercase b here, lowercase c there, okay? What we know is that your calculator, and I'll just show you on mine, okay, has sin, cos, tan. That stands for sine, the sine ratio, the cosine ratio, and the tangent ratio, okay? So you should remember ratios, right? Ratios are two numbers being compared, okay? So what we know is this, and it goes into more detail, which I will do when we get to that chapter in a little while. We know that if you want to take the sine ratio of angle A, later on these will be numbers, right? The sine ratio of angle A, right? That would be equal to, so if you say sine of A, what is it going to be equal to? It's going to be equal to, I'll do this, the opposite side over hypotenuse. Okay. The cosine of angle A would be the adjacent side divided by the hypotenuse. Okay. And tangent, the tan ratio of angle A, these three here will eventually be numbers, okay? The colored entries. Tangent would be opposite divided by the adjacent. Okay, and I will give you the formulas. I will give you something to help you remember. So think about this, right? S O H, right? So I'm going to highlight that. 1 second. All right, you have A, angle A, O, H, and here you have A. Sorry, I didn't mean to do A. Sorry, I want to do sine SCT, right? The first letters of the trig ratio, and then the first letters of the sides, okay? So to remember that sine is opposite over hypotenuse, we do this. We call this so. I go S for sine, opposite hypotenuse. And remember, the order matters. So opposite would go first, hypotenuse would go underneath. So this helps you remember, oh, for sine, I need these two sides because you only need two. Notice that there's no adjacent here in this mix. For cosine, you need adjacent over hypotenuse. So, ka, and then for tangent to remember, tangent is opposite over adjacent. Notice that couple things. Sine and cosine both take the hypotenuse and the denominator, right? Tangent is the only one that would relate opposite and adjacent, right? So this is the acronym I want you to remember, Sohcahtoa. If you have heard of it, great. If not, no big deal, okay? Let's just go over here and knowing that this is true, right? Looking at this triangle, sine of A would then be something. Sine of cosine, sorry. Cosine of A would equal to something, and tangent of A would equal to something. So let's just put the letters in, right? Because we know that there will be two sides coming in here. So based on this triangle right here, maybe we should label, right? This would be the hypotenuse. This would be the opposite. And so the last one must be the adjacent. So if sine calls for opposite divided by hypotenuse. In this case, the opposite side is A. So we would put A down and the hypotenuse is C. For cosine, cosine calls for ca should help you, right? Adjacent over hypotenuse. My adjacent side in this case is B, and the hypotenuse is still C. Okay. Tangent of A, what's tangent again? Toa, right? Opposite over adjacent. So I go here, the opposite side is A, the adjacent side is B. So this is telling you what goes where, and this is actually just grabbing the sides, and later on these will be numbers, and putting them in there. Okay. Now, this is basically a crash course into this unit, which we will cover in detail later on, but I always find that there's not enough time. So make sure you have this all written down on loose leaf. Call this trigonometry at the very top. Okay, this is chapter 7 of what we're actually going to cover. So this is an intro, and then we're going to do examples now. How do we use this to actually solve for something? Okay, so let's go backside. So we're going to start with solving for side lengths. Later on, we're going to solve for angles, right? Right now, we're just going to stick with side lengths. So let's do our first example. So let's say you have a triangle like this. And let's say that this is 5 inches. And this angle right here is 30 degrees. So that's how we oftentimes you'll have like an arc here and a number right beside it, but sometimes just a number. But that's telling you that this opening is 30 degrees, okay? If you put a protractor, right, you can measure the angles of something. And let's say in this particular case, the question is asking you to solve for this side here, okay? So all you have is an angle and a side length. And you know you cannot use Pythagorean theorem because you need at least 2 sides, okay? So what we're going to do here is, this is my reference angle right here, okay? This is where I'm located. Let's label the 3 sides that are always in play, okay? Across the 90, this is the hypotenuse, so just go hip, right? The one across is the opposite. And so this must be the adjacent side. Now, there's always one side that you won't know what it is, and you also don't care about it. And that is the adjacent in this case. So I want you to say, this is the don't know, don't care side. Don't know, don't care either, right? Like it's not asking me to find it. So we're going to focus on these 2 sides here. For now, I want you to always have this written down. Sohcahtoa, because that's going to help you determine which one. You can only go with one of these. You can't use either sine or cosine or tan. Like only one of them works. So in this case, you just look at the 2 sides that are left. Which ones are left? It's the opposite and the hypotenuse. So which one of these 3 ratios has the opposite and the hypotenuse at the same time? Opposite and adjacent, nope. Adjacent, hypotenuse, nope. Opposite and adjacent, this is the one. Okay, you gotta use, we use sine, okay? So now you've narrowed it down that out of the 3, only this one will work. Okay, because the O, I'm going to use a different color. The O is, I'm going to make, just get an arrow. It's like, okay, the O is there, and the H is there. Okay, yeah, there's an H here, but there's no O, right? It has to be the 2 sides that are at play here. So now we're going to go ahead and start setting this up. And once you set this up, it's actually fairly easy. This is probably the hardest part in order to get it right. So I'm going to follow this. You never use so in your math, okay? It's just to help you determine which trig ratio are you going to use. Because again, it's either sine, it's either cosine, or it's either tan. If you don't have a calculator with these buttons, get one, okay? Because you're going to need it. If you're using your phone in the meantime, if you turn it sideways, you will don't just have your phone facing this way, face it sideways, and then you get the scientific calculator. But I would not recommend that, and you're not going to be able to use it for any tests or quizzes, okay? So let's go back. Sine. So this tells me that I have to use sine, and you just do sin, right? Sin of the angle, right? I'm going to call this A for now. I'm just going to tell you that's the angle. And it asks for opposite divided by h, which is the hypotenuse. Very critical that you know that. Down the road, you're not even going to write this down anymore. So let's go. Sin of the angle. What's the angle? It's this one right here. So you put in the number. So I'm going to write down a value in there. 30 degrees is equal to, and you always put this line down because you know there's going to be numbers going in here. It's asking for opposite here, right? Which one is your opposite side? It's unknown. So you write down x. The hypotenuse, which is supposed to go down here, it's 5. So you put the 5 down here. And you have it set up, right? Now you have it set up. And now there's a little trick. Remember, this might take you back, right? Remember that 5 is the same thing as saying 5 over 1. They're the same thing, okay? So instead of 5, 5 over 1. So this is what we're going to do here. Sine of 30 is actually just a number. You will see that in a bit. So I'm just going to say this. Hey, I'm going to put a 1 underneath it. Now it should look like a proportion to you. Okay? So you cross multiply and divide. So this is just a little trick to help you. It's like, oh, okay, I'm going to have to cross multiply and divide. So it's going to be 5 times sine of 30 divided by 1. Okay? So you go x is equal to 5 times sine of 30, write it down like that, divided by 1. And then I'll show you what it looks like on your calculator. Actually, I'm just going to do it next to it because I want to use this for another example. So x is equal to, let's go here. Watch what I'm going to do here. I will tell you this. Could you have had sine of 30 in front and then the 5 behind it? Yes. But I would always recommend to put the actual value, the number, in front of whether it be sine, cosine, or whatever. I would always recommend that because sometimes some calculators, if you put the 5 and the 30 next to it, it might complain or might give you a wrong value. So this is 5 times sine of 30. And so that's 2.5. 2.5 what? Inches. Because you're finding a side length. And so now you have found that this side up here, the opposite side, is actually 2.5 inches long. Okay? Now, some issues that you might have, make sure your calculator is set to degrees. Okay, so I don't know if you can see it, it's hard to see. There's a little D there. And some of you can change that by pressing, in my calculator, I have to go to mode again, and then it's degrees, radians, or gradients. You don't worry about these two. It's degrees that you want, so I would have to go 1. Some of you have a DRG button, which if you keep pressing it, it will rotate through those. You got to make sure you have a D there, okay? Or else you'll get a completely different answer. Okay, so that's what it is. Okay, let's do another example. I'll write it down first and then I'll keep recording because otherwise it'll just be a long video. Actually, no, I'll just continue. Okay. So let's say I'm going to make it look different so you're not getting too used to the one way of presenting it to you. Okay. So let's add a little bit more to the mix here. Let's go, this is D, E, F. And we're gonna make this be 40 degrees. And we're gonna have the, make this be the unknown here. So we're gonna call this side E. We don't know what it is. Okay. And we were gonna know that this is 17.5 centimeters. Okay, so this side length right here is 17.5 centimeters. E, which is across from angle E, is unknown to us. And this is going to be our don't know, don't care side. Okay, so copy this down. And let's get started. So the first thing I'm going to ask you to do is always label. Label first. This is the angle in question here. This is my reference angle, so to speak, because that's the one they're giving me. So I'm situated here. So across the 90, this is the hypotenuse. Across from the angle that is given to you is opposite. This one is my don't know, don't care. Okay, so I don't worry about this one. I'm just gonna scratch it like that for now. I don't want you to do it down the road, but for now that's what it is. So O and H again, okay? So Sohcahtoa, right? So you're asking yourself which one has O and H, right? Because you're looking at the first letter. O and H is sine, so you got to use sine. Sine of the angle. Sine is always glued to the angle, folks. Always. Okay, it's like right next to each other. Is equal to, on the other side, you'll have opposite. So, right, because this is asking for opposite. So that has to come first. So this is 17.5 over, in this case, we call this E, right? Because you go with the letter that they're giving you. So this is my setup. I do the little trick, put the 1 here, and I see you can't cross multiply there because there's a variable, but you can cross multiply here. Okay, so what's going to happen is that this is going to help you to know, do I divide or do I multiply, right? So E, side E is going to be 17.5 times 1, right? Divided by sine of 40. Now, I encourage you to use your calculators as you're working along because sometimes you have some issues with calculating these things. And it's because your calculator is different than mine. Okay, so I'm going to do this over here. Okay. So I go 17.5 times 1, which is just 17.5. I'm going to go divided by sine of 40. If you don't have a two-liner, you're going to have a bit of an issue, and I will show you how that's done in a bit. Anyway, so that I get 27.23, and what units am I in? I'm in centimeters. And watch this. This is my hypotenuse that I found, right? Oh, 2 decimals, okay? The 5 bumps that to a 3. Okay. This is the hypotenuse, which should be the longest side, and so far we are where we're supposed to be. It's longer than the one leg that you're given, still the leg, right? These are still the two legs when you're using Pythagorean theorem, but the hypotenuse is the longest, okay? So there you have it. Let's do some examples where it's not sine necessarily. Okay, for now, since you might be stuck using a calculator, you should have a good one by now, but let's say you have issues coming up with this, right? You're stuck here. First of all, you have to turn it sideways. Okay, you have to turn your cell phone sideways, and then you should see sine, cosine, tan. You should always make sure it's set to degrees. So look at this, there's a rad here. So if you press rad, then now you're in radians, right? So you should be pressing degrees, and then there's nothing there, but now you're in degrees. So it's only the two options. So 17.5 divided by sine of 40, you're going to have to type it in differently. You're going to have to go 40 sine, then press equal, okay? That's when you're going to get the right answer. Because if you go sine 40, it's not going to work. You're going to have to go 40 sine, then it gives you that 0 point whatever, right? And so equal one more time, then you get 27.23. Okay, so that's the way to do it if you're using this, but I do not recommend it. Go get a decent calculator, spend 15 bucks. You still have grade 11 and 12 left with two lines where you put it in and where you get the answer, then you don't have to worry about that. Okay. All right, let's do our next example. So write it down. You can pause the video, right? Because this is not live. Okay, so let's label. This is the I'm guessing I'm going to start with the hypotenuse. The hypotenuse is the don't know, don't care side, so I'm not going to worry about it. Okay. Next is your reference is here now, so it's a little different, but that's where the angle is. So across from it is the opposite. So this must be the adjacent side. This is the don't know, don't care. So out of the three ratios, right? Sohcahtoa, right? Which one is it going to be? Well, let's see. O and H. So O and A. O and H, nope. A and H, nope. O and A is this one. Because O and A, the first one just tells you you're going to use tan, but you don't worry about that just yet. You first look at the two letters that follow the capital. Okay, so O and A are at play here, and tangent is what you're using. So you will use tan. Remember, it always needs an angle, is equal to, and the order matters. O first. So what's O in this case? It's B, side B. So it's a variable, it's an unknown. And the adjacent is 0.35. And there you have it. You put the 1 under this ratio, because remember, like tan of anything, sine of anything, tan, cosine, it's just a number. Watch. If you go tan of 65, you hit equals, it's just a number. It's a long number, right? The decimals continue on, but it's just a number, so don't be scared of it. It's your friend. So cross multiplying in this case would mean multiplying these two guys together. So B is 0.35. I always take the number first, times tan of 65 degrees divided by 1, right? And here you can, I don't want you to go equals next to this proportion. You write down the work and then you come up with that, okay? So that's 0.75 feet. Okay, so that's your answer there. Question. Could you now use the Pythagorean theorem to find that third side? Because now you have this, you have that. Absolutely, you can. We're going to do that later. Okay, let's do one more. And then I'm going to give you a worksheet to try. Okay, it's going to be under classwork. So I'll pause it. Okay, so copy this down. Determine the value of z, and it's lowercase. And it's triangle, right? I'm going to say in triangle x, y, z. Okay? Determine the value of z, that should be lowercase, in triangle x, y, z. Because if it asks you for what's the value of z, like capital, we usually, like if you refer to angle, this is angle z, right? This is an angle. If it's just z, then it's a side. Okay? So write it down, pause it if you need to. Across from this, that's the side they're asking for. Okay? Label the 3 sides. Of course, we're only going to label 2, but start with the 90 degree, find it. So we do care about this one, so hypotenuse. If this is the angle, because that's given, you move out. This would be the opposite side. We don't care about it, so this must be the adjacent, which we are given. So again, okay, A and H, or H and A, right? Those are the 2 sides. So you look at the 2 sides. A and H, it's ca, right? Cosine. So this helps you set it up. That's why we teach it to you that way. So cosine of the angle, and it's a decimal as an angle, no problem, is equal to adjacent. So that comes first, right? Adjacent. So it's almost like you do it this way, right? You always go angle over down. So adjacent is 125.4 and z is your unknown. We put the 1 here, so it's really the same after you set it up. In this case, you cross multiply here and you divide by that. So z is equal to 125.4 times 1 divided by cosine of 23.5 degrees. Z, so watch how you do this, right? 125.4 times 1, which is just 125.4, divided by cosine of 23.5, and that is 136.74. And what units are we in? Kilometers, because we're finding side lengths, right? Later on, we're going to find the angle. We're not going to know the angle. They're going to give us sides, okay? But there it is, okay? I'm going to do an added note here. Determine the length of y. Like you're asking for y now, okay? Well, let's just retrace that one. We know that z is 136.74. We know that this is 125.4. We want to know what this is. Okay, so remember Pythagoras, right? Use the Pythagorean Theorem. So in a sense, this is a leg, right? A missing leg. I don't know if you remember the review, but to get, right, side y in this case, this is side y, this is z, and this is, sorry, this is x, right? Because it's across from angle x. So to get y, it's essentially square root of, and you're missing a leg, so that would be a subtraction, right? So 136.74 squared minus 125.4 squared. If you missed this, if you forgot this, go back to the intro videos that I did, right? So you go 136.74 squared the first week of school. Those videos are called, if you go to classwork, they are there. So you get this and the square root. And square root that, so you get 54.52, and we are in kilometers. So once you have the 2 sides, you use the trig, and then you can use Pythagoras to find the rest. Okay, now in Google Classroom, go to classwork. I'm gonna, obviously this video you will have watched already, it's there, and then you will work on that worksheet that I will post there, okay? So and there will be a look under Friday, October 2nd, okay? That's where you look for the material. So essentially, just listen up, okay? So one of the groups is always going to be in here, writing it here, okay? The quiz. So you're doing this while a different group is writing the quiz here. So remember, I'll write it down here so you have that. So make sure. So for the groups that are not writing the quiz, right? You're home. You will have met me in Google Meet, and I would have told you to do all this. You work on this trig stuff, okay? You work through the worksheet that I post. I might post more, and that's your task to become really good at doing trig when it comes to solving sides. Okay, so watch the video again, look through your notes, and that's it for now. Okay, so we should resume regular classes on Wednesday, right? We're back to normal Wednesday, October 7th, so we're going to do chapter 2. So the booklets are there. Also, I now decided I'm going to give you all the booklets for all the units so that you have them just in case, all right? So as you come through here, starting this Friday, I'm going to just give you all the booklets. If you don't have it, ask for it, okay? It's just in case I forget. All right, that's it for now.